Okay, so probably the first thing that's worth mentioning is that, we're going to talk about submodules and SSH keys, pull requests, and webhooks. That's really the thing we're going to do. We actually have 3 labs today. So just to mention the specific labs, we are going to talk about, we're going to do a lab on SSH keys, a lab on pull requests, and a lab on webhooks. I'm going to, just a reminder in case you missed this, I am going to give you an email within 24 hours that's going to have a wealth of resources about not only everything we're going to talk about, including subtrees and submodules, which are just ways of embedding repositories beneath repositories, but I'll give you some fundamentals as well. So there's like little bite-sized videos, including this fun little website that I really enjoy. If for those of you who maybe are just like starting to understand Git branching, is what is it called? LearnGitBranching.js. There's this great little website, which actually I'll post in chat. If you haven't done this little tutorial website, this tutorial allows you to visualize. You can just close that. This little tutorial allows you to visualize how your commits and your view of the commits kind of like work together. So this is called LearnGitBranching.js. If you've never seen it before, it's a great little website to kind of like learn how Git branching works and how to move your like pane of glass to different commits and branches. So like, for example, every time here you make a commit, what will happen is it'll move it forward a branch, right? And so if you branch things out, it'll show all the visualizations and everything. So it's a great little website. Plus it has a great little tutorial for learning how all of this functions, including rebasing and merging and some other concepts. So this is going to be part of the email that I send you, but this is a great website to learn the fundamentals of Git, right? And so that's LearnGitBranching.js, and I actually pasted it in the chat as well. Okay. So let's do a little wordplay for a second before we actually dive into this content. So tell me what GitLab, GitHub, Bitbucket, and all of the other SCM tools, what do they have in common? Can anyone tell me what they all have in common? What's the underlying technology that they have in common with each other? Right. They are basically DevOps tools. Where is this thing? Zebia Labs used to have a periodic table of DevOps tools. Let's take a look at this thing. Here it is. So by the way, if you've never seen this, this is a fun little tool. It's not comprehensive by any stretch of the imagination, but this used to be owned by another company, but Digital AI bought it. This used to be the periodic table of DevOps tools. And what happens is if you look up here and we're looking for like source code management, my brain has completely stopped working. Right, if you look over here, it's like it shows Git and Subversion and GitHub and GitLab and Bitbucket, and I don't even know what CompuWare ISPW is, frankly. And it lists Subversion because oddly enough, there actually are people still using Subversion. But most of us, the vast majority of companies now are all using Git repositories. I do know some people in some larger, older companies who are still using Subversion for their stuff. But this is basically like the link for like source code management, right? Which is different than artifact or package management, which artifact or package management isn't really about managing source code per se. It's about managing the bundles of source code that are now like packaged for deployment. That's really what an artifact is. And this could include third-party libraries. So source control management, which is what an SCM is, right, is really what GitLab and GitHub and Bitbucket and all these tools do, is that they are source code management systems. Now, some of them are hosted, like, like GitLab, for example, has an on-premise product and an off-premise product. So does Atlassian's Bitbucket, right? And so you can go SaaS or you can go local, although everyone seems to be moving more towards the SaaS model, depending on what your security requirements are. And so when we take a look at a website like GitHub has an example, GitHub, and I'm already logged in this particular case. Let me log out really quick. GitHub is basically just, as their advertisement says, it's where the world builds software. Now, the funny thing is that a couple of years ago, I'm going to say, maybe it's been 18 months, but my memory is kind of fuzzy, so maybe that's not accurate. they really were a source code management system that just hung out in the cloud. They were just a way for you to host Git repositories out on a third-party location. But then what happened is that they decided to become more active, because really the only competition that was really strong at the time was a build server called Jenkins. And don't get me wrong, GitLab was there. I have friends who work for GitLab. They've been around for a while. There's like Travis CI and Circle CI. There were other companies that were kind of emerging to handle continuous integration and continuous delivery / deployment. So GitHub said, you know what? This is where all the action happens, is in these Git repositories. Let's add some ability to do manipulation to these repositories. So they came up with GitHub Actions. And that was kind of an evolution of kind of where they were headed to begin with. But GitHub is really just a host for Git. And most of us know that. So like I have another login for Git, because I have two for today's little fun experiment. And like underneath my user ID, I've got a bunch of repositories. Some of these repositories are under organizations. Some of these repositories under just my ID. Some of them are public, some of them are private, but all of these are Git repos. That's basically what they are. And so, for example, this class, we code 3107. This is just a super clean repository that we use just for testing purposes. But there's other repositories out here, God, I don't think I've touched MSD React in a while, but like since February 2020. But like there's stuff like this out here, right? Where it's like, there's a repository, and it was semi-active at the time that I was using it, but I haven't touched it in a second. So, all GitHub really does at a base level is it's just a way to host Git repositories. If you want to go somewhere beyond that, then you've got to like configure workflows and extra features and integrations in with other tools. And so if we were using GitLab, it'd be similar, right? But some of the lingo and the terminology is different, because GitLab operates more as a CI/CD server and not just a Git hosting repository, right? And when I say CI/CD server, I'm talking about continuous integration, continuous delivery, which means how do I manage, test, and like, in a sense, secure the merging of changes into a deployable branch? That's continuous integration. And then continuous delivery is then how do I build and test all that right up until I get to production's door, meaning I'm about to go out to production. That's continuous delivery. And continuous deployment is where once I hit a commit and I do CI and it passes all the tests for continuous integration and my merges go in and it's totally fine, how do I then build that package, test it, run it through environments, and then deploy right out into production? That's continuous deployment. So to rehash that, continuous integration really happens around the repo, and it's how do I get my changes merged in a sane, compliant way, tested way, into my deployable branch. Whereas continuous delivery is then how do I take that working code, package it up, test it even further, maybe even do some integration, some regression tests, smoke tests, all that stuff, all the way up until it's ready to go right out into production, but it stops right before it gets to production. So that's continuous delivery. Continuous deployment is that it just goes right out to production. And maybe there's a methodology there, like we do A/B testing, or we do canary testing, or we do some kind of linear rollout where I roll the new version of software out to a small subset of clients, test it for a period of time, and if everything looks good, I roll it out to a larger set of clients, and then a larger set of clients. And as long as there's no errors, the next thing you know, I've rolled out a whole new version of software, and it's being used by all the clients because I'm getting no errors and usability looks good and no one's reporting a problem and I'm not seeing a problem. So that's CI, continuous delivery. So continuous integration, continuous delivery, continuous deployment, right? So that's what these systems are really for. Now, let's say that we're using one of my repositories, and I've decided that in order for me to use my repository, I need to actually pull in another repository, because I want to pull in the React framework, for example, or I want to pull in a Trickster framework, or I want to pull in something that someone else is working on in another repository, but I want to pull it into my repository because I'm going to use the framework. But occasionally I also want to update the framework. So I'm going to do that so I can actually like keep two repositories inside the same framework. So that's really where the concept of subtrees and submodules comes in, which is what we're going to talk about now, which is how do I pull in other people's repository code into my system and maintain them as distinct systems that can stay in lockstep with each other, but also how do I manage that? Because I'm pulling in somebody else's repository. How does that happen? So this is what we're going to talk about now. Okay. So here's the funky thing. There's actually kind of two ways to kind of pull this off, if you will, to put a repository inside of someone else's Git repository, and like yours, right? Is that if you need to share artifacts, binaries, source codes, files, or whatnot, you can actually put a repository inside someone else's repository. Like you can pull somebody else's into yours if you want to. And you can do this through either what's called submodules or subtrees, but they're used for kind of relatively distinct purposes. So this does create a dependency, by the way, because you're now sticking in your repository someone else's repository at a certain version, tag, release, right, number, if you will. Now, there's a number of tools, by the way, that will do this for you automatically. But the reason you do that is because you want their code inside your code. You need it for some reason. Again, a framework, a binary, some kind of library that you're importing into your code. So if you're working as a developer and you don't want to recreate the wheel, you might take someone else's wheel and pull it into your system. Now, there's a number of tools that will offer some kind of dependency management, like Apache Maven, NPM, which is the node package manager, will do that for you. And then, of course, Python's pip. Like, for example, to pick on Python for a second, if you stick in your repository a requirements.txt that has a list of all the software, when you run pip, it will download that software into, in a sense, almost as like submodules inside of your systems, inside of your repository, as like additional code that you've added to the repository. And usually just to use these tools, it's the right choice. Because then that way you're not having to manage dependencies. You just say, look, I pulled down this repository. It's got a list of dependent software. I'm going to pip install it, and it's just going to go in and pull all the requirements down. So the goal is that we're trying to create a repeatable build, but we're using a third-party repository. We're using somebody else's repo, or maybe it's another team. It doesn't necessarily have to be like outside the company. It could be another team's repository. So this allows you, by the way, to build artifacts based on these repositories and kind of keep them in lockstep or even roll them back to different versions. So we're doing this because we want to create the same build behavior every single time. Now, when you're doing dependency management, just to say this, usually explicitly making your own subtree or your own submodule inside of a repository is not the best idea, honestly. Let me just say that right up front. Usually manually using subtrees and submodules is somewhat out of favor because almost every language now has some kind of dependency package manager. So if it's Python, it's pip. If it's Node, it's NPM, right? If it's Ruby, it's Ruby gems, right? Gems, right? So again, what you might do instead of creating a submodule and a subtree is you might create your own pip package. You might create your own NPM package. You might create your own gem package and just pull that in as a dependency and just use that existing dependency system instead of going straight for submodules or subtrees to pull in your repos. So I'm just throwing that out there because that's typically what people will do now is they'll generate their own, right? If it's Java, for example, they'll use Maven or Gradle to pull down dependencies. And you might say, well, Michael, hold on. How would I do that actually? Wouldn't I need to then have a pip server? Wouldn't I then need to have an NPM server? Wouldn't I then need to have some kind of gem hosted server because I don't want to share my code out with the world? And to say this is that you would actually, right? And to draw this out a little bit, just to get kind of give a little bit of a visual. Here we go. We've got our repository, right, in pink. And what we've decided is that we've decided to pull in a third-party library. And let's say we decided to pull in a number of third-party libraries. Again, you could create subtrees and submodules for this, or Instead, like if you're using Artifactory or Nexus or one of the other kind of like artifact hosting tools, you could have a server out there, and that server could contain, for example, the library that you want to pull down located over here. And what would happen is that you would just use the industry standard tools, and the industry standard tools would allow you to, for example, that when you initialize this repo and you ran, say, pip or Maven or Gradle or any of the build dependency tools, you could then just pull this module down as part of running those dependencies. So again, I just want to make sure I express this, is that that tends to be what the industry favors over explicitly running submodules and subtrees, but that's not always possible. So this is where submodules and subtrees come around. Okay. Does the concept of embedding other people's code inside of a repository, does that make sense? Does anyone need clarification on that? Okay. Now it says right here, by the way, you'll notice this, it says, by the way, sometimes we can't use dependency management, right? Like for example, older code that doesn't necessarily have great dependency managers, although I think even now, like C, I want to say like through Crystal or Elixir, I could be getting that wrong, has like dependency managers now. So sometimes we can't do that. It's not an option. Okay, now this is where things get interesting, is that if you need to embed someone else's code, in a sense, underneath your primary system, your primary repository, you can use submodules, which allows you to embed a repository underneath a repository. So think of it as a directory that sits underneath the core directory that you can use to, right, basically house somebody else's code. Once you're inside that subdirectory module, by the way, and it's part of your overall repository, you can actually independently pull just an update for that submodule and not necessarily make changes per se to the core main repository. So you can modify files in the submodule and then push them back to the original repo, and you can like clone, if you, in a sense, the parent repo to get a repeatable reference to snapshots of modules. Submodules are really, really good when you plan on pushing a lot to that submodule. That's where they're really awesome. This is when you actually really want to use submodules, is they are preferred when you're planning on pushing, right? Just to say this also, submodules have a smaller repository size since they're really just links that point to a specific commit that's out on the other repository. The difference here, just to say this, is that Git subtrees are going to house the entire child project. So let me give you an example. If I am pulling the React framework into my system manually, I'm not going to use npm, I'm going to pull it in manually into my repository. If it's a submodule, the submodule is just going to be a link to the latest like head and or tag of React, and I'm going to get a copy of that. Whereas if I do a subtree instead of a submodule, I'm going to pull that entire repo down. All of its refs are going to get pulled down into my repository, and I can squash it, but just so you know, I'm still going to pull it down and then I'm going to squash it, right? But I'm going to pull the entire child project along with its history if I do a subtree. If I do a submodule, it's just a link. It's a reference to that remote third repository. That's all it is. So, and just to say this, because it is just a link, I will need continual access. If I do anything to that repository, I need continual access to that link. So, you know, and to make this other distinction, when you're using submodules, which is just a subdirectory inside of a Git repo, you're doing component-based development, meaning everything is like a component, right? If I do subtrees, I'm doing system-based development. Very different ways of doing things. And if you're like, we don't know if we're doing component or if we don't know if we're doing system-based development, yeah, we need to look at your product to really figure that out. So again, submodules are literally just directories underneath that pull just a reference to that remote repository. So submodules are just a link to another repository, really. Now, that being said, adding a submodule is really as distinct as just typing in git submodule add, the URL of the remote repository, and the path that you wanted to send at. This is literally going to clone like the repository in its current state down, right? And so the name's going to come from the repository name or a path if supplied. By the way, if you don't supply as a path, which is optional, it will just clone it underneath your main, right? By default, it's going to clone the master branch of the repository unless you actually specify -- branch. So it's not going to grab all the branches and all the commit history and It's literally just going to grab the master branch. By the way, it says master branch of the repository. What has GitHub renamed most of their master branches to for new repositories? Does anybody know? What has GitHub changed all of its like master branches? What does it rename them to for all new repositories? What are they called now? No one's run into this problem. No one's run into this challenge. The great change. Was it last year or was it earlier this year? Oh, so just so you know, master is now main, right? They now call it main, right? Be aware of that if you initialize a new repository and you wonder why your CI/CD server is pulling off a master and nothing's happening. It's because now it's called main, right? Is that new? Hopefully it's not news. Probably most of you just forgot, right? But yeah, it's called main. Okay, so if you add a submodule, by the way, just note also that inside that directory that your repository is sitting in, you're now going to have a subdirectory. It's going to contain your code, right? If you cd into that submodule, you're going to see that there's actually no .git directory. Like, as an example. All right, assuming I can actually type the words clear. Let's see. My current working path is that I'm at the W30107 repository. If I take a look here, there's actually a .git directory, right, inside of this. Now, if I go to .git, right, notice that right now, you know, there's some refs, and if there were any hooks, there's in there. Like, this is where all of the Git information is stored and managed, is inside this .git directory. Now, let's say I was out here and it's like, you know what? I really want to add a submodule, right? So I want to run git submodule add in the repo URL. Let's see if I have a public repo I can pull this off of. Where did I stick all this? Oh yeah, let's pull you off actually for a second. So let's say I want to, what would make sense here? Oh yeah, you know what? Let's grab this SCP policy. That makes sense. So let's say I'm going to go back here and I want to do a git submodule add. And I'm just going to like grab this repository. Oh, interesting. Oh, oh, hold on one second. One branch tag, we're all good there. So branches are working. Is there something wrong with this repository? My demo has gone horribly awry. So you don't like it? Oh, that's so weird. I didn't even do anything. That's so strange. Anyway, did you see that get through an error, by the way? Did you see that? The main reason, by the way, it didn't like that, I think it didn't like the fact that I was actually in the Git directory. So what happened is I was in the .git directory and it didn't like that. You're not really supposed to do anything in the .git directory. So let that be a lesson for all of us. It's like, don't do anything in the .git directory. It actually was right to stop me because I wouldn't actually want to stick it there. That's fine. So notice that what it did is it basically copied this other directory, sorry, this other repository. And now if we look, notice there's now a subdirectory called AWS SCP. And you might say, Michael, what is AWS SCP? Well, it's this other repository that's out there. So I've got this other repository called AWS SCP out there. And what I did is I just pulled it in as a module, right? Now, if we go look at AWS SCP, here's the funny thing. This, in a sense, is a Git repo. Oh, but let's go take a look at this Git directory. Oh, it's not a directory. What is that exactly, right? It's probably most likely a reference. Notice it has a reference to where the actual like Git directory is for this, right? So in this particular case, if I actually go back up one level, back to my like base repo, which is WA3107, and if we look in the .git directory, you won't necessarily see like anything like super funky here, right? But if we were to peel this back, right, you see that there's still a main. Let's go take a look at remotes. We still got an origin. Let's see what's going on with origin. Oops. Still only have a main reference here, right? Anything with tags? Anything changes here? Nope, haven't really made any tag changes. So then what happened? What happened exactly? Well, what it did is it actually took that code, took a copy of it, right? Pulled it down, but then it embedded inside all of the Git directories and embedded all just that single reference of where that directory was at that particular point in time. So if we go back and look at AWSCP, notice that it actually did pull down the 2 policy files that are inside that repository, right? But notice it only grabbed main. It didn't grab any branches, right? So if we look at the Git status here, looks like everything's clean, everything's looking good. But all it did is it would pull everything that was on main because I didn't specify a branch. I didn't say, when I said git modules add, I didn't specify a -- branch and say, look, I want this branch out of the AWS SCP module. So this is, by the way, a way using submodules to embed this other repository inside my current repository. This is how you set that up. Now I can do other things. I can do submodule add. I can do merges, pushes, pulls. Like I can do all kinds of stuff. The typical things that you would do with a repository, you can do with a submodule. There is a great cheat sheet that I was going to share with you. I didn't dig this up. Where did I even grab this thing from? I think it was off of devroom.io. There's a great cheat sheet here about adding a submodule, for example, including path to submodule, commits, right? If you want to clone a project that contains submodules, there's kind of a few extra steps to take. So if you pull somebody else's repo down and it has submodules in it, you actually have to go in and actually initialize the submodules and then update them if you want to grab them, right? You can do, by the way, a recursive clone, if you will, by basically just saying, look, I want you to recurse the submodules in one step. And then if you're looking to just simply like, you know, if you're just simply tracking the master branch for the submodule, you can just do like a fetch and a merge. So there's a couple of different pieces here, right? If you want to track a specific version, right? If you want to update the remote, if you want to remove a submodule, right? You can deinitialize the submodule, remove that particular path, and then basically commit at that point in time. So I'm going to put this cheat sheet obviously inside the email that I send you, but there's only a few things that you need to do in order to like maintain submodules. Most of the time, again, you're going to use submodules over subtrees if you want to keep your repository slim and you only want a reference to the module and you're going to do some pushes back to the third-party code. If you're not going to do pushes to a third-party code, subtrees tend to be better, right? Just throw that out there. Let's see, other things to talk about. The Git modules file is your public list of Git modules, and it's version controlled and will be cloned with the repository. Let's see here. Git modules files in your public list of submodules, right? So it will list all your submodules, version controlled, and be like basically cloned with your repository. I have to say I don't remember. It's usually located in the top level of the working tree, but for some reason, oh, you know what? Because I'm in the wrong directory. There it is. All right. So if we cat git modules, this will actually list all the modules that you have. So notice in this particular case, AWS SCP, there's the path, there's the original URL to actually grab the module. So when you do a git submodules init, when you pull down somebody else's repository and it has modules in it, it actually pulls this file, and this is the file it reads to know what modules are available inside that repository. When you do a git submodules update, it will then also update those modules as well based on what's listed here. So Git assumes, by the way, that you'll need to configure submodules, right? So for instance, you might need a different path to a submodule, especially if you're going to do modifications. So it's just a reference list. So if you need to initialize the local repo to use the submodules, as we looked at when we were looking at the cheat sheet, you've got a submodule init first, right? This is going to add entries to .git/config, and it's going to add entries to .git modules. And it says that you can edit .config manually or with git config. I'd probably use git config just to say this. Editing the git files manually can sometimes be tricky. So after you basically initialize a submodule, right? When you pull it off of somebody else's repo, you can then update the module, right? By using submodule update. So this is going to actually clone the submodule. So it won't just initialize it, it'll actually check it out, right? It's going to check it out, by the way, at the same commit that was at the head when the parent module was checked in. So, note that a branch is not maintained. It is checked out in a detached head mode. And you can enter the module and select git checkout branch if you want to commit on a certain branch inside the submodule. So just know that branching still applies inside of submodules, including you pushing back on a certain branch. So just be mindful is that submodules get managed just like a standard Git repository, but they are cloned and initialized just slightly differently. So git submodule add, git submodule init, and git submodule update are going to be your most commonly run commands against submodules. Notice that doing a pull on the parent project is not going to typically add changes to the submodules, right? So you're going to need to actually enter into the submodule in order to basically either fetch or pull or possibly merge, right? As it sees fit. There is a, you can run a git submodule command and say for each, I want to run this command. So you can actually do a pull or a merge or a fetch against all of your submodules if you want to. So, yeah. Just taking a quick note there. All right. Any questions about submodules? Okay. One thing that's interesting is that no one asked me what the difference was between a fetch and a pull. Does anyone know what the difference is between a fetch and a pull? Some of you developers who are constantly working with this, do you know? That was good. One you should do over the other, Grain. But tell me more if you don't mind. Do you do fetches or pulls usually? Yeah, typically we do pulls. We don't use fetch. I'm surprised it's even listed here, honestly. Fetch, by the way, allows you to pull the changes down from another repository. If you're tracking that repository, it allows you to fetch the changes, but it doesn't merge them. It just pulls the changes down. It doesn't merge them against your local files, right? So it doesn't really pull them into your local setup, if you will. A pull fetches and then merges those changes into your local file. So if there's any discrepancies or differences, it'll tell you, right? But it actually merges the files in so you can actually like work on them. Fetches, if you, I'm just like capturing or tracking the changes. So in general, you're going to do either a git pull or a git submodule for each git pull. Like you're going to do it that way. You're not going to do a fetch typically. Does anyone use fetch on a regular basis? I'm just kind of curious. It really varies based on the team's methodology, but I don't really know of many teams that use fetch on a daily basis. Does anyone, any of you all doing that? Yeah, I didn't think so. Just to say this, most of us use Git in a relatively limited way inside of our IDE, which is totally fine, right? Because most of us abhor merge conflicts. Does anybody else abhor merge conflicts? Having to figure out like how two branches got merged together and you're trying to figure out how to unmuck somebody else's changes because you both changed the same file at the same time. Yeah, so that's pretty common. Let's see. Oh, one thing I was going to do is I was actually going to de-init that directory. So that might be a fun, like how to remove a submodule. Let's do that really quick. Where are you? Okay. All right, so let's say this is here. It's my particular submodule. And so what I'm going to do is the first thing I'm going to do is I'm going to de-init the module, right? And so in this case, it's just AWS SCP, right? Yeah, no, we're gonna discard them. Oh, that's weird. I haven't seen that before. Is that a Windows thing? It must be a Windows thing. I'm on Git Bash on Windows. Let's see. And then what we're gonna do is we are going to remove the path, right? So we're gonna get RM and then AWS SCP. Oh, once again, I see what's happening here. You're asking for very specific things. Okay, so I did a get RM to remove it. And then what's going to happen here is that I'm just going to do a quick git commit. And that's it. And so now that module has been removed out of the system. And so AWS SCP is no longer there. It's out. And so if we take a look at a cat at get modules, sorry, right? Basically it says nothing. There's no submodules, so nothing else is listed here. So all references were removed from the .git directory, including the config file and the modules directory. And now the .git modules file also has no references to a submodule. Okay, quick quiz before we go into subtrees. Everyone type in the command and you don't have to use a URL, but type in the first 3 words of the command to add a submodule to a Git repository. Perfect. Git submodule, not submodules, but submodule add. Excellent. Okay, other question. I have downloaded someone else's repository and it has submodules in it. Now, just because I git cloned it doesn't mean that I have the submodules. What's the first thing I need to do to initialize those submodules inside my repository clone that I just pulled? What's the three first words to initialize a repository, a submodule? Okay. Good. Good. Remember, not plural, right? Single word, submodule. Okay, good. Now, what's the command I type if I need to actually clone those files into my local repository? I just cloned somebody else's repository. It has submodules. I just initialized them. So we now know about the modules. We've now connected to the remote. What if I want to clone them down? What's the next step after init? I've added it. Sorry, I've cloned it. I've initted it. What's the thing I have to do afterwards to actually get the files into my local repo? What's the command? There we go. Git submodule update. Julian, just +1. That's it. Good. Yeah, so Git submodule update. Okay. All right, so here's a bonus module. Here's a bonus question, one that you wouldn't necessarily be expected to know. What's the first command I use to remove, right, a submodule out of a system? What's the first command? Think about how you did things before. You cloned a repository, then you initialized it, then you update it. What do I need to do, right? Good. Get submodule dinit. Perfect. Good, good, good. The rest of it, by the way, you can figure out by looking at the syntax, right? But typically it's just a path. It's just a URL. It's the second command. If you want to change the path, the local path, you can just add a directory after that if you want to. Okay. Other questions? So I said that you are more likely to use submodules if you are doing this more frequently to the submodule. What did I say? I said you would use submodules over subtrees if you were doing this more frequently to the submodule. What is the this? What are you doing more frequently to the submodule that you would want to use a subtree for? I'm sorry, not a subtree, a submodule. Yeah, updates, pushing. That's exactly right. So if you're doing updates or pushing upstream to the remote, you're probably going to want to use the submodule because it just makes that a lot easier, right? Okay, so which one is larger? A submodule or a subtree? Which one of those is larger? Yeah, subtree is larger. Good. Just to say this, submodules make it easier to push. Subtrees are easier to pull. Okay. Good. Any questions thus far? Excellent. Okay. So then let's talk about subtrees. All right. So subtrees are alternatives to submodules. It avoids some of the complication, doesn't necessarily need any special handling. And by the way, most of the time you may not even be aware if you're using somebody else's repo. I am so sorry. It's fall here and I'm just really loving the weather, but it's got me really chill. You may not be aware, by the way, that you're using a subtree. So you only really need to think about subtrees when you're updating or pushing back to the subtree's original source, which again is why if you're doing that very frequently, you're probably going to use the submodule. You're not going to use the subtree, right? The concept can be a little confusing though, right? Because what a subtree command actually does is it allows you to merge basically someone else's entire code base, including commit history, underneath yours, right? So unlike submodules where it's kind of treated as its own independent repository, and so therefore it pulls, pushes, and merges separately, a subtree is just pulled right into the target repo, right? Including, by the way, the entire commit history of the repository. You can squash it, but just to be clear, you are going to pull the entire history down and then you're going to squash it. So if you're the user who pulled it, it's going to show up into your Git history, just so you know. Okay, so let's take a look. So you got two repositories, big project and the lib or the lib, right? And so you want to have big project use the lib as a source level dependency. Now, what you could do is you could just add the lib as a remote, like make it so that you got both code bases, the remote like links inside your local repository. This actually doesn't work, by the way. It's just a fantasy, right? And you would get a tree like this, right, where the lib files are right next to the big project files, and that may not be what you wanted because the lib file is just a library. So maybe you don't need the libraries on the root directory for whatever reason. Maybe that's a little messy. But what if you could pull the library's files into a subdirectory, right? And this is really what the git subtree command does, right? So here we've got git subtree add. There's a prefix, and in this case, it just says the lib, right? And then what happens is then, it says ... the lib, and then master. Seems like there's something weird about that command, but I'm going to ignore it for a second. Right? I'm just going to ignore that presented command. And so what ends up happening is then you have a tree that, like, let's say your repository is called big projects, and then you've got files underneath that project that are right there, like big project file 1. And then you've now got a subdirectory called the lib, and then you got the lib files. Does this look exactly like submodules? Seems like it, right? It's pretty much what this command does. So let's go fumble around a little bit in our demo here. And let me go grab where's my module one more time? Or did I pull it back over? Oh yeah, I did pull it back over. Let's pull it back over here. All right, let me copy this repository again. Okay, so git subtree add -- prefix a prefix, and then ... the lib, right? Master. What I'm questioning is this particular command, but let's run it as stated and let's see what happens, right? So weird. Something about that's really throwing me off. Anyway, git subtree add. Let's see, AWS SCP. Oh, I see. I gotcha. I wonder if this will actually work. Let's see what they're doing now. I'm going to do master, by the way, just to see what happens. By the way, why did that fail? Someone tell me, because I told you this earlier. Why did that fail, by the way? Thanks, Matthew. Yeah. Thank you, Kristen. Yeah, of course. It's like there's right. Like this repository was just recently created, right? So as you probably know, and by the way, all of you people who are new or not familiar with Git, you're probably like, what? As part of like kind of the improvement to just language in general, they removed references to master and newer repos. So if you initialize a repo now on GitHub, and I think it's been true of like the last 6 to 8 months, instead of calling the core kind of like root branch, if you will, master, which is what comes with every system, it now initializes, it's called main, right? Now notice the minute I added main in there, oh good, right? Now notice instead of doing ... / the lib, which was just a directory reference in that particular thing, what I did instead is that I added a URL. So I added my GitHub URL in this case. So to break this down, it was git subtree add. Here was my prefix, right? Which, think of this as kind of like specifying a directory, right? And then what happened is that I then added my full URL to the repository that I wanted as a subtree, and then I specified a branch. So notice this is a little different, right? Now, if I go into AWS SCP, I'm ahead of main by 4 commits. It's funny. Notice I've now added this whole subtree in. So I have the entire history, by the way, of AWS SCP in here, right? So, oh, that's right. That's an alias in my other box. So notice here, by the way, it has all the commits from AWS SCP. Oh, look at this. There's all this stuff here. So notice that all of the history from ACP is now listed here. Because just to say this, creating this policy file and creating this policy file, they were not part of the WA3107, the like root repo. They're not part of it. This is history from the ACP repo. Now I could squash that by putting a -- squash on that and squash it down, right? But notice that here it is. Notice also, by the way, that the initial README commit for origin main is here. So it merged the histories of the systems. Just to say this, generally, if you're going to use subtrees, you're going to squash it so that all you get is the whatever the last commit history was. That's it, right? So all right, so further things. So with the above command, the entire history of that other repository, AWS SCP, was pulled into WA 3107. I mentioned that you can use the squash option, to squash it all down to one commit. Notice that you can pull or push from a source repo by using that git tree subtree command, right? By the way, that ref could be a branch, a tag, a commit ID. It doesn't have to be main or master or whatever it could be, whatever you want to pull off, right? And that's it. Now, a couple of things I want to mention, because there's I have another great cheat sheet for you, right, around git subtrees, right? So notice here that using git subtree, you can add one, you could pull one, you could merge one, you could split one, right? And so subtrees allow, like as we stated, allow you to basically include them as subdirectories. A git pull will typically pull everything in, right? So it's really just that simple. I don't know there was anything else that I wanted to talk about other than squash. God, that's the entire command, actually. That's an interesting cheat sheet. Pardon me for just 1 second as I look through it. Actually, I have a better cheat sheet. That one came recommended from Red Hat, but I think I'm going to actually pull in another one. So maybe from the dev room, right? So we'll find another one. But regardless, I'll find a better cheat sheet. But there's not a whole lot of commands for git module. For git subtree. So that's it. Pull, push, right? Yeah, there's not anything else to add there. All right, so catch. Subtree is going to load the entire other repository down. So it's no longer a reference, right? You're actually literally like pulling that entire, it's almost like a fork, if you will. You're like pulling the entire thing down for your consumption. Again, remember, submodules are ideal if you're wanting to do a lot of pushbacks to origin, back to the remote. And git subtrees are better if you're just doing like frequent pulls. I got to tell you again, and I cannot emphasize this enough, submodules and subtrees are in a way kind of the old ways of doing things. I would say instead that whatever your language is, think about using a dependency manager like a pip or a Maven or a Gradle and store your artifacts, like pull in your libraries through your artifact repository. Use gem, use something along those lines. Unless you just have an absolutely compelling reason to use submodules, which is what I would actually recommend that you use. Okay. Grian, yeah. So can I say more about squashing history? Like more about like what that means? Sure. So squashing history means that, for example, if this whole history that we were looking at before, instead of pulling in all of the repository's history, because I purposely used simple, clean repositories that only had a few commits on them. I even initialized a new repository for this because I couldn't find one that didn't have 500 commits on it. If instead I was pulling in a repository that had 500 commits on it, and I was like, I don't need that. I don't want to have a subtree. I don't need to pull in the entire commit history. What I want is I just want the last commit history. You can use -- squash, and what that does is it condenses all of the history, and it basically brings it in as one last commit. And so instead of seeing 500 entries now merged into my history, you're going to see one entry, right, which will be the last commit entry, right, that will now show up into my system. And so it basically condenses all the history down for the remote repo down to one commit. So you don't have to necessarily get 500 commits worth of history inside of your repository. So that's what squashing does, is it squashes it down. It condenses it down to one commit. All right. Okay. So that's git submodules and subtrees. All right, so questions for you. If I want to basically initialize a Git subtree, like I want to like create one, how do I do that? What's the command if I want to like create a subtree? I want to bring a remote repository into my system. What are the first three pieces of the command? Git subtree add. Good. All right. If I wanted to do a pull or a push, just give me one version of those if I wanted to do that to a subtree. Good. Either one's fine. Excellent. By the way, what comes after git add or what comes after git push? It's something that you put after it that specifies where it's going to go, right? What is that called? It's got a weird name to it because it's not a directory. Yeah. By the way, if I wanted to not do dash dash prefix and I wanted to shorten it, does anybody know what the shorthand is for dash dash prefix? It follows standard Linux convention, by the way. No, it's just dash capital P. That's all it is. If you don't want to type out prefix. Good. Okay. So we've been going for about 70 minutes now, give or take, introductions. So here's what we're going to do before we actually move into our next section is that the end of username and password. That's funny. We're going to talk about SSH keys next, but we're going to take a break. And by the way, we're going to just take a little bit of a break pretty much at the top of every hour, give or take or so. So it's let's say 9:10 right now. We're going to take an 11-minute break. So come back at 9:20 and we're going to hop into GitHub and we're going to start doing some things on GitHub. Okay. So we'll see you in about 11 minutes. I'll put up a little timer. Okay. Okay. Questions? Okay. Let's talk about them. Let's have a conversation about GitHub actually in particular. Okay. So this is a little bit more specifically about GitHub itself. So notice that just recently, GitHub decided that they were no longer going to accept username and passwords for operations. Now you might say, wow, why would they do that? Like what prompted this move? And what ended up happening is that, as some of you who may administer systems know, we have moved away from using username and passwords for almost 10 years now. Username and passwords as far as an industry standard are typically not used anymore to manage like remote systems. Typically what we do is we have what's known as key pairs, and there's a private key and a public key. And what happens is that the public key goes on the system and we keep the private key. So in a sense, we've shifted away from using username and passwords, and we've gone from public private key pairs. Let me explain this in a little bit more detail so this makes sense. I'm gonna draw it out. I'm just gonna do a short little simple annotation here. Let's say that using cryptography, you generate a key pair that has two parts. There's the green public part, and there's the red private part, right? And this comes in two files, right? An identity key that just says key.pub, and another key that says, well, I'm just a key, and it's a private key. And let's say that you've got a bunch of servers out there that you want to log into. What will happen is that instead of using password authentication to, let's say, log a particular like user into these systems, what will happen is that we're going to take the public key, not the private key. We're going to take the public key, and we're going to stick that public key and associate it with the user on these disparate systems. And what happens is that when we want to connect to these systems, we're going to authenticate with our private key, which only we have to get into these systems. And like a fingerprinted key, since we're the only ones who have the private key, and we are only ones who have the private key associated with our username, what's going to happen is that that private key is going to fit and mesh with the public key from a mathematical standpoint. It's going to say, oh, that's the private key. That is the only mathematical match that I have. And then it's going to let you log into the system. It's all math. It's all cryptography. So what we're going to do is that GitHub now requires you to use either a token like that or some kind of public private key pair in order to authenticate into the system. Now, you're the only one that has the public key associated with your username, and you're the only one with the private key. So when you come in, you're submitting a username and you're submitting your private key, which can only match to that public key that's associated with your username. But here's the problem. How does the public key get up there? By the way, if you're working in a server or in cloud environment, or let's say you're working with Ansible, so I know that we have at least one Ansible person on here. How does that public key end up on the server that you're logging into and associated with the username? Anyone tell me? Prasad, that's right. While provisioning the instance, If there's 10 users that are supposed to have access to that box, Ansible is going to basically associate with those 10 users. It's going to configure it so that they know what public key is associated with those users. And as long as those 10 users have their private keys and submit them when they connect to the servers, they're going to get in. But my point to all of that is that it has to be provisioned / configured. And that's what we're going to do in our lab is we're going to provision / configure this. Okay. Now, I know that I didn't get into the cryptography or the different key bit lengths and all the different types and all that stuff, but does that basic concept make sense? Which basically says this private key stays with you. You don't share it with anybody, and it sits on your box and only your box, nobody else's box. And this public key is going to get shared with a bunch of different systems, and these two are linked together. Does that make sense to everybody? Those basic statements. Good. I know most of you are like, dude, I've been dealing with this for a long time. Because I know that's what you say in your head. You say the word dude before you have thoughts, right? Just kidding. All right. Now, GitHub will accept obviously multiple token types. So if it gets it from an official OAuth provider, or if it's a GitHub app token, there's a bunch of ways to do that. Or you can use SSH keys. So just know that there's many different ways to submit that mathematical identifier to GitHub. I just showed you SSH keys. Okay. But you can create personal access tokens. Hub.docker.com. If you've dealt with Docker, wow, I'm just making up my own technologies over here. That's going to be my new Docker is Docker. If you use Docker, by the way, you have to create a personal access token in order to privatize your connections. They don't use SSH keys. They generate a token that you then copy down, and you just submit that token with every request, or you use it as a login. So there's lots of alternatives, but basically what it comes down to is that, do you have a mathematical key that will allow you to get into the system? That's what all of this gets down to. This is a mathematical key. Now, some people will confuse SSH and SSL/TLS, right? Which underlying, they're pretty much based. They both use public key encryption. They're very similar technologies. I'm not even sure honestly why this is here. Just know that since GitHub has moved away from using HTTPS, which is what TLS would be piggybacking over, it's mainly using SSH now. Now remember this relationship, right? You've got a public key matched to a private key. This is a key pair. These two together, that's key pair. You can encrypt with the public key and then decrypt with the private key. You can also encrypt with the private key and decrypt. These two are matched. This is peanut butter and chocolate. But here's the difference. The public key is everywhere that you want to log into. You're the only one that has the private key. The private key is truly private and should not be shared with anybody. It is literally an identifier for your username. And we want usernames to match one user. One username, one key pair. Now, the steps to do this for GitHub are pretty straightforward. Let's just generate a key pair. By the way, when I generate a key pair, how many keys is it going to generate? 5, 10, 2, 15? Thank you. 2. Good. One's going to be public, one's going to be private. Then you're going to store a key pair. Just to mention this, most tools that use key pairs are very sensitive about the permissions of the directories that you store key pairs in. If you store it in a directory that is writable, like the whole world can actually read the directory, most tools do not like that. So just know you're not going to stick it on a shared directory. Most tools are not going to like that. You can also then configure your SSH agent if you want to do that. And then you can register your public key with the other provider. We use a tool called SSH Keygen, which has been around forever, and it's part of the Open SSL toolkit to generate our SSH key pairs. Notice that there is a ton of choices around algorithms to use. In general, most people are moving towards, sorry, my shoulder's a little out, moving towards this ED 255.19 has a new, more secure algorithm because DSA is no longer considered secure, and ECDSA says it may contain a backdoor. So, you know, by default, it usually defaults to RSA. I'm just going to tell you this. If you use RSA, use a 4096-bit key. And you can man the page if you want to do that, but I believe it's a -B to set the bits, -T to set the type. But if you're just intentional about it, use the ED 255.19, right, as your like algorithm, your mathematical method that you use to generate your key pairs. Use ED 2519. By the way, you might say, well, what if it's not compatible on the other side? Hold on, wait for a second. If you are generating both the private pair and the public pair that you're going to stick out there, then your methodology is going to be the same because you're going to generate both files using the same command. So you don't have to worry about mathematical incompatibility. You are literally making a whole cookie, and then you're breaking the cookie in half and then giving half to the public side, and you're keeping the private half for yourself. So you don't have to worry about compatibility. Now, typically, SSH Keygen will store the key pair in a key store if you're on a Mac. If you want to store it in a key store, you don't have to store it in a key store. Using Java, you probably put it in the key store. And you can create a passphrase. I just want to tell you, if you're doing automatic runs, like using it for a script, you're not going to create a passphrase because the passphrase requires you to interactively input the passphrase. If you want a more secure login, you can put a passphrase on your key pair, and you will be required to stick that passphrase / password in every time you execute that key pair. That can get annoying, but it's also a lot more secure. So consider that. The SSH agent, by the way, is a way of just kind of keeping your private key available to use for authentication. A lot of that's actually done for you in a lot of systems, like a Mac, and even to a certain degree with Linux. I don't know that I've ever even seen that run on Windows. It might be there, but I don't know that I've ever seen SSH agent run on Windows. I know you can run it, but I don't think it runs by default, but don't quote me on that. Most of the time, as long as you're submitting it on the wire, you don't necessarily need to keep it in memory. Now, since you're sticking this out on GitHub, you're going to keep the private key. GitHub is going to get the public key. You're going to add the key to GitHub in the settings menu. Where exactly? Well, let me show you actually. So first, someone tell me, all you big engineering brains out there, someone tell me exactly where on Linux, on Mac, or on Windows it stores your keys when you generate a key using SSH Keygen. Did I softball that up? Yeah, good. Good, I'm glad you saw that. But I know some of you were already typing it. Yes, Prasad, if you're the root user, it's going to put it under root, right? If you're IT Amazonian, it's going to put it under IT Amazonian. But what the bottom line is, it's going to stick it into a .ssh directory. Now, just looking at this right here, which of the algorithms is it using to generate this key pair? Someone tell me. Yeah, it's using RSA, right? I'm gonna control C that, by the way. I don't want it to finish. So it's going to store it in the .ssh directory. So if we go to my home directory, Michael. Okay, So tell me which one of these is the private key file. Which one of these is my private file? Thank you. So that means the other one's public, right? Because it actually says pub on it, right? Now, if I catted my RSA file, you might get access to a bunch of things, right? But if I cat my pub file, that I can share with everybody. Now, I just want to point something out. See how this one ends with like a Q equals equals, right? So it's got a BUQ equals equals over here. See that? BUQ equals equals, right? Starts with 4 A's. Just has something to zero in on. If I take this entire thing, this is my pub file, right? And I copy it. And I go over here to GitHub and I click on my portrait and I go over to settings down at the bottom. It's going to take me to way too many options. Can we all agree that this is probably way too many options? There's a lot of options here. Okay. Now, you might think to yourself, well, hold on, Michael, isn't this fall under account security? No, not really. Oh, I don't have two-factor enabled. What was I thinking? Anyway, I gotta fix that. Two-factor is enabled, not enabled. It's actually under SSH and GPG keys. So it's actually down here. So notice, by the way, that it's going to say, hey, you know what? It's actually this one, the All Might CLI, because this one's been used for the last like week or so. It's got a SHA fingerprint on it, which I could actually use to fingerprint my file. But what happens is I'm going to click on new SSH key. And what I would do is I would literally just paste it here. Notice it begins with SSH RSA. Notice that from their perspective, it needs to begin, right, with whatever protocol I'm using. If you use the ED 25519, one of these is going to show up. Okay. So this is where I add it. Once I add it, I can put a name on it, and then this will allow GitHub, as long as I submit the right key, it will accept that because it's going to know exactly who we're talking about. It's going to know that it's me, right? Well, also there's a URL like a repository being added, so it knows that as well. And so once you add the SSH key, what happens is it then shows up here with whatever name you've given it. Really, did I do that? Oh yeah, I did do that. I had to buy another laptop. I don't know where this virtual machine is though. This thing is just gone. I'm just gonna go ahead and delete that key right there. All right. So, by the way, if you delete a key, you can always repaste it in here. It's not like it's irrevocably gone, right? I don't have any GPG keys if you're using GPG, but this is mainly how you do it, SSH keys. Okay. So this is the intention here, is for us to do these, to set up our systems so that we can get this functioning. Now, I just want to mention this. At this point, all of you should have gotten a email. Hold on. Where is it? Virtual Lab. Because we're going to switch to labs. By the way, are there any questions about anything that I just covered as far as the SSH keys go? Because you're about to do it. Okay. Really? You're not going to let me pull this out? That's very weird. Oh, there you are. Okay, so can everybody see my screen? Does anyone not see their name up here? Because as far as I can just eyeballing it, I think everybody's name is here. Yeah. Okay, good. So if you see your name here, I just want to say this. That means ideally you've gotten this email. Might be in your spam folder. And what I want you to do is I want you to go ahead and use this login down here, this WASadmin labs WASadmin, to log in through HTTPS. You can use RDP if RDP is available, which I don't even know if it is. Yeah, it's down at the bottom. But honestly, in most corporate environments, RDP is going to be flaky, especially if you have a VPN connection. You're going to want to use your browser for this. Make sure you use either Chrome or Firefox. So because RDP is typically not going to work. Yeah, Christian, I think that's pretty standard actually. So thank you for confirming. Okay, do me a favor. Once you get logged in, I want you to go on the Zoom bar, hit the three dots if you have to, click on reactions, and give me a, a green yes. Just like I did. That way I can just look at your fabulous profiles. Let's see. Web-based support. Oh yeah, so the mail subject, by the way, is just virtual lab and then dash. By the way, one of the quickest ways to get logged in is that this link actually is pretty generic. It's actually just the same for all of you. It's actually just this. But what's different is that your PC name is different, right? So you actually don't need the link. This link is just generic, actually. It's right. All you need is actually your PC name. So like, for example, Ralph, yours is ends in a 108, right? You just need your PC name and then the username and password instructions down here, which is really just WASadmin labs. It's labs / WASadmin. By the way, if you want to see this in action, let's see. My computer name is instructor, right? So just paste instructor. It's going to be labs WASadmin, and then WASadmin is going to be the right. So good. Okay. Wow, that resolution. That's really intense, actually. Let's see here. Let's move annotation. Okay. Wow, that's a clean looking Ubuntu desktop. I haven't seen that one before. By the way, oh, what is this? Oh, it's the lab guide. Look at that for convenience. Most of us look at that remotely. Okay, so we're going to actually do lab 1 where we're going to create SSH keys with GitHub. Just to say this, creating a GitHub account nowadays is actually a fun little exercise. Oops, hello. So if you go out here to GitHub, and let's say you log out. By the way, so I'm sorry, unless we're being very clear, you are working on lab 1. You can completely ignore me and go at your own pace, or you can follow. I'm not going to work through the whole thing, but I just wanted to show you this little piece, which is tons of fun. So you can, by the way, do this on a local browser. You don't have to do it inside the virtual machine, at least not this piece, right? So let's say that you want to sign up for GitHub. First of all, they have one of the greatest sign up processes I've ever seen in the history of sign up processes. So notice here that I actually signed up with a student email, and I'm actually going to do a second one. So what will happen is that that's actually just going to go to my IT Amazonian email. And let's say I want Spartan Sage 3. I do not want to see product updates. And then it's going to ask you a puzzle because it wants you to verify who you are. So notice that I actually set an email, set a password, set my username. You can go back, by the way, and click on these and change them. I don't want to get marketing information. And I'm going to click on the spiral galaxy, and there's 1 done. I'm going to pick on another spiral galaxy. There's 2 done. And then it's going to say, oh, do you want to create an account? Let's do it. Now, the first thing it's going to do is it's going to send me an email with a launch code inside of it. Why? Because it's trying to verify that I'm a human being, right? So let's get our launch code. So in this particular case, it is 092255. I press enter. Boom. That's going to ask me a couple of questions. Just know that the lab does actually have some specific things it wants you to answer here. So you're just going to say like maybe 2 to 5 members, say you're a student, then continue. You can check like the first 2 boxes if you want to, as far as like which features you're using, but don't check more than that if you can help it. Then click on continue. And then what's going to happen is it's going to give you this really dark free on the left-hand side. Notice that they actually darken the button, so you can't even really see that there's a continue for free, because you can also apply for student benefits, but we're just going to continue for free. And then it does this cool little page where it like shoots you into a nebula, initialize your dashboard, and voila, you are now registered inside GitHub. By the way, this assumes you don't already have one, but you can create a new one also. So we are working on lab 1 right now, creating our SSH keys. Okay. So finish out parts 1, which is create a GitHub account, which you just saw me do. Part 2 is create a remote GitHub repository. Part 3 is to create a local repository. Part 4 is to connect the 2. Then you're going to create a key pair, and then you're going to put the key pair up there. Okay. So that's it. So I'm going to leave you alone and stop talking, but that's what our focus is going to be for the next 15 or 20 minutes is let's finish that out. If you have any questions.
Will we get a student email address or?
Sorry, what do you mean, Andrea?
Yeah, should we, each of us should create an extra email or do we get a student email address?
A student email address. Oh, do you mean, do we provide you an email address?
Mm-hmm.
No. You can either use your personal or your private to create another GitHub account. If you saw on mine, if you're using a Gmail, Yahoo, or Microsoft account, you can just put a plus sign after your username, and then it will go actually to your base email. So if you put plus student 1 or plus student 2 after a Gmail, Yahoo, or MSN Live or Micro Outlook account, it'll actually just go to your base account. So you can use whatever email addresses you have on hand if you want. Or you can use an existing account. You might say, Michael, I already got an account. I don't need another one. The only catch with using the Sanofi account is that they might be looking for that, and they might filter for it, but I don't know that. So we'll see. Most corporations do look and filter for that. Right. That was fun, but yeah, unfortunately, we can't spend more time on it. It stinks. I love that. Okay. So nope, not you. Let's try you. Okay. So pull requests. All right. So then why were pull requests so important that they wanted to talk about them? Like, okay, so we talked about submodules, we talked about subtrees, we talked about get submodules, submodule command, get subtree command, right? So we talked about initializing submodules and adding subtrees. Okay, so then why are we now talking about pull requests? All right, so pull requests were initially like a defining feature for GitHub. And if you use GitHub Flow, excuse me, pull requests are a thing, right? And what it does is it allows you to accept some, like when, let's say Christian generates a pull request against my account, what Christian is doing is he's saying, Michael, I am creating a request for you to pull my code into your code base. That whole thing around like pull requests is important because that's, I mean, those merges, like when you're working in Git as a developer or an infrastructure engineer, you have to get comfortable with conflict because merging people's code from one branch into your deployable branch, that's all you do all day long, really, is resolve conflict. Now, there's ways to minimize that, but it's pretty common. And so pull requests are basically a flexible way for you to say, I want you to merge your code in, but in a sense, like I want your approval. Like I need someone to look at it. Like I want an interactive process. I either want you to peer review it, or you're like, I want you to interact with it in some form or fashion. This drives collaboration and is one of the reasons why pull requests are kind of popular, but in some circles, pull requests are also considered to be, well, now I've got another gate before I can commit code and then deploy it into production because I got to get somebody else to look at it. So there's two perspectives on pull requests where one is like, yay, someone else will look at my code and make sure I haven't made any glaring mistakes. There's another perspective on pull requests where it's like, oh my God, now I've got to get somebody else to look at my stuff. And what if everybody's busy, right? I now have to wait for someone to make time to look at my pull requests before I can merge that code in. So before pull requests, what would happen is there'd be a system of locks. And so one user at a time could like check out a file for editing. So you didn't have to worry about somebody else doing it. This is like Subversion, by the way. Multiple users, by the way, could check out a read-only version of the file, but they could not check out an editable version of the file. Once the person who checked out the file for editing pushed that change back in, then someone else could pull that file for editing. As you can imagine, this is very linear and it creates a lot of lock-in, and it really locks, the movement of a repository down to one user really at a time, making changes on one file. So not ideal. So since we often have to work on the same files at the same time, sometimes files could be locked accidentally, or like someone go on vacation, or users would get frustrated and go around the locking system. Those were all issues, right? It just didn't create flow. So GitHub and Git, by subsequent, depending on the different branching strategies that you use, are designed because this is the way developers really work, right? You want multiple branches of the same code in different phases of lifecycle. Team members can edit any of the files at any time, and the team members are working in a distributed system where we have copies of the files and we are then doing a pull request to merge our stuff either back into main, but particularly on the remote, right? We're pushing them back into the central repository. So people create a fork or a copy of the repository, they make their changes locally, the changes do not affect the original, and then what happens is that once they're done with their changes, they're going to create a PR, a pull request, to merge the new code on their local system into the original. The keeper of the original repository may accept the change code, or they might send comments and questions back to the requester. When the PR has been approved, when the code changes have been approved, then the remote changes are merged into the original repository. Yeah. So when you create a pull request, you need basically two accounts. And what happens is you're going to review the changes, you're going to enter comments, and then you're going to create the pull request, right? And so here, let's say that you're like want to create a PR because you want to like commit to another repository. Notice that you'll see like there's something changed down here, right? It's going to actually show the differences. You might have comments in there about like how this was done and why, and why this was an important change. And so you create the pull request. And then when you respond to a pull request, You're going to review the code changes, review the comments, send any questions, and push back to review if necessary. And then once all your questions are asked, if you're the reviewer, you just accept the pull request, and then it merges it into the remote like origin, if you will. And that's a pull request. Now here's the horrible / fun thing is we're going to go back in and see if we can get access to, like, we're going to create a pull request. Okay, so that's actually our next lab. Now, before I do that, I am just going to take a second, and I'm actually going to talk about webhooks, because webhooks is a relatively short topic, and this will enable us to just focus on labs for the remainder of the time. That way, if we start running over, we're not going to get tense. So I'm going to go over webhooks just relatively quickly. And so we're going to talk about pull requests, and then I'm going to talk about webhooks, and then we're going to do a lab on both. Okay. I just want to make sure that you do not walk out of here without me at least reviewing the topics. And now we're going to do 2 labs. Okay. So unlike pull requests, which allow us to submit our local changes, commit them, and then say, hey, I would like to push this back to the master repository, like the primary main repository. Unlike pull requests, which do this, webhooks serve a completely different function. The main purpose of webhooks is to trigger an event based on either before a commit, or it can be a variety of actions, or after an action. So these are asynchronous. Usually it can like push a payload or push some information. They are very configurable, and they typically will target like a URL, like a build server. So how it works is that an event occurs in app A. App A is going to package the relevant data and then post the data to app B. App B receives the post and then processes the data. This is typically the interaction between like a repository and a build server, for example, right? And so you could send a webhook to an email app to email a client when a payment is received. Like, for example, you could post into an email application, like a service that's listening. You can post to a build server. You could send a webhook like when a student like starts an exam, like an app, right? For example. Now, in this case, we're mainly talking about repositories. You could also have an app send a webhook to another app. Now, again, we're framing this all up mainly as it relates to repositories, but webhooks can just be used between application and application. So it's not just something unique to GitHub or Git repositories. Webhooks can be used to just hook in one app to another app. Now, GitHub supports webhooks. It supports a bunch of different payloads. You can submit it in XML and JSON headers. You can specify event-specific properties. And you can create webhooks just like you can in any Git repository. And you can create pre and post webhooks, which means before an action or after an action. This is typically done so that when someone does a commit, it talks to the build server. That is the most common thing. You can also trigger testing. You can trigger security scans. You can, trigger like a static code analysis if you wanted to, which is what SonarQube typically does. There is a ridiculous number of events, right? Because it can be triggered based on whatever event is happening. Someone makes a comment on a commit, someone deletes a file, like there's it's like all stages of actions that GitHub can support. Here are some properties. Like, what was the action? Did someone just make a comment on my commit? Awesome. Who was the sender? What repository did the event occur in? Was there an organization? Was it part of an organization, or was it just my personal repo, right? And if you have GitHub apps, like what was the installation, right? Which is a whole different can of worms in and of itself. And of course, you can parse headers for those webhooks as well, right? So what's the event? What's the delivery ID? So as the webhook is submitted, you can actually parse the XML or JSON, but the header of the post, the HTTP post. So to enable webhooks, you just go into settings, right? You look at webhooks, and then you can set the URL, set the content type, choose the events that are going to trigger the hook, if you will, like the push or the post, really, right? You can make the webhook active, which is required for the webhook to run. So that's something to be mindful of. And then you just add the webhook, and then it's automatically in your webhooks list. Now, I just want to say this one little thing about webhooks before we do the labs. If you are trying to hook a repository that's out on the internet against a build server that's in your enterprise, what's the single number one problem you're going to run into? So you got a public service, you got an enterprise that has a build server inside the corporate network, and you're going to try and initiate communication from the GitHub service over to your build server. What's going to be the problem? Yeah, Matthew, it's going to be the firewall and a security issue, which is why the firewall is there. So just so you know, I mean, you can talk to them and ask them to punch a hole. GitHub, by the way, publishes a known list of all the IP addresses that they come from. This doesn't matter. Most security teams are not going to like that. They're going to say, well, just get your build server to poll the thing. And you're going to be like, well, that's going to be chatty, because how often do you want me to poll? And you know, it's like, you're going to poll every 60 seconds. You're going to poll every 5 minutes. You're going to poll every hour, right? Or you could just go in there and just hit push on the build. I know that's a manual process. That's not what we want. My point being is that most security teams are going to ask you to do a poll from the internal network to the external service, and they're not going to let you punch a hole in the firewall. So just keep that in mind. There are ways around that, tons of ways around it, but that's typically the resistance, just FYI. Okay. So webhooks are mainly used to trigger a response to an event inside of a repository. That's what they're used for. What's the event? Any event, any of the 60 now event types that are defined inside of GitHub that you can do with a repository. What can you post? Anything that will actually fit against the URL is either a web post with an XML or JSON payload. So that's up to you. Okay, it's a lot. Probably be worth mentioning that GitHub Actions is kind of an enhanced version of webhooks, and that GitHub Actions allows you to do a lot of event-driven kind of actions, if you will, based on events. And but it goes further in that it will actually integrate you in with servers. It'll actually integrate you in with like cloud providers, or integrate you in with GitLab, or integrate you in with Jenkins. Same problem applies though. If you want GitHub to talk to your server, someone needs to either punch a hole in the firewall and make an allow list for the GitHub IP addresses, because it could come from any of those IP addresses. Okay. Questions about either the general purpose of a webhook as far as integration goes, or anything that we talked about around just like a pull request? Okay, so let's switch back over to labs then. So lab one was us to set up SSH keys with GitHub. Now what we're going to do is we're going to create a pull request. But just to say this is that you're actually going to need a second account. If you already have two accounts, like you had one that you already had and you just created a second one, you can use those, right? But just know you need a primary account and a secondary account to pull off this lab. So for those of you who are doing the labs, go ahead and kick off lab 2, and that's going to be what we're going to work on. But you are going to create a second account in order to be able to have those two accounts. Okay. And let's see, were there any gotchas with this? You're going to create another repo, by the way. So you're going to create a new public repository. This one, by the way, they want you to call website. So just FYI. You're going to add some HTML. You're going to fork and modify the repository. I don't think there was any gotchas in this. You're going to create a PR. So you're going to create a PR just for you to talk to you. Okay. Accept the pull request and then just see it run. And then once you're done with lab 2, you're going to run over to lab 3, which is going to actually have you create a webhook. So, all right, so let's get to it. I'm here. We'll troubleshoot as usual. Let's roll on to labs 2 and 3.
Can the second account have the same email address than the first account?
I don't think you can create two accounts with the same email address, but you can do what I did, especially if you're using a Gmail account. So for example, my normal email address looks like this, but you can actually do this, put a plus sign and then add like student one or account two or whatever you want. Here's an example. Oops, ignore that gmail.com. If you put a plus sign with either a Gmail, a Yahoo, or a Microsoft account, you can put anything after that you want, and it's actually going to go to your primary email, but it'll treat it like a second email address.
But this only works with gmail.com or also with other providers?
It generally works with other providers. So I've seen it work with Yahoo, and I've seen it work with Outlook, with MSN, Hotmail, that kind of thing.
Okay, thank you.
Yeah.
I'm sorry, Michael. I created another account here, but which one would be the primary? Is it my first, I mean, the old one or the new one? I mean, or I can choose between.
You get to choose between, doesn't matter.
Okay, thank you.
Sorry, Michael.
Yes, go right ahead, Matthew.
Are we doing lab 3 only or lab 2 also?
No, we're doing lab 2 and lab 3.
Okay. Okay. Thanks.
Yeah, absolutely. Let's see. Has everyone wraps up for the day? I know that some of you are finished. If you're finished with labs 2 and 3, that's the last of the content. The only thing I was going to add is that I just posted an awesome Git list out there by DICTCP. It's it's not touched but like once a year or so, but Git hasn't honestly changed a whole lot other than GitHub changing. So there's a curated Git list and there's a curated GitHub list, which is the other list I like to post. So this is by a gentleman that I don't know actually, but these are both awesome lists with a bunch of resources. I will be sending both of these links and some of the links I sent earlier out to you. So you will get an email from me. It usually takes a business day, so it'll usually be like Monday at lunch. But you will get a follow-up email. In addition, there is a evaluation to take for this. Let me pull it up. I will also send that an email, but it would be really great if you could fill it out today as well. do note that the evaluation is read by the learning and development team and by the CEO. So, you know, if you want different classes or you want to make modifications or anything that you put in there, it will actually be read. So you will get a voice. So just know the eval is posted. So all I ask before you leave is do the evaluation, and then yeah, hopefully I'll see you in another class. I'll be covering Ansible, AWS, Terraform, which I know some of you are taking Terraform with me already, and other classes. So if you want different things, just let us know. Okay. Thank you for being here today, and thank you for doing the labs and going through the material. I know that a lot of you had different expectations, but please put that in the evaluation. Say, look, we need a GitHub or whatever you need. This was a very curated list of topics. So regardless, I'm going to still be here, but I'm just letting you know because I know some people have already finished labs 2 and 3. Okay.
The virtual machines which we use will be deleted at some time, right?
Yeah, so usually end of day on Monday, they'll be deleted.
Okay.
So you'll have access to them for the next 3 or 4 days.
And on our account, on our GitHub account, we can just delete the repository, or
You can do whatever you want. You want to delete the repository, you want to make it private, you want to delete your account, you can do that as well if you created a secondary account. But once you're done with the repository, you can do with it what you want. There's a push. Funny. Oh, Prasad, thank you. Yeah, absolutely. Please, by all means. Thank you for being here, and thank you for your assistance, by the way. Love
Thank
it.
you, Michael. Yeah.
Yeah.
Thank you.
Yeah. Well, and I'm sure we'll talk again because you're on the Ansible side of things, correct?
Sure. Yeah.
Yeah.
Definitely.
All right.
Yeah.
Have a great night.
All right.
Thank you.
You too. Bye bye.
Well, I just ran through those labs again. And it was nice to see that, as I remembered from last week, there were no issues. Definitely gonna figure out the other stuff though for lab 1. Okay, keep working. I'm here. I'm gonna be quiet. Oh, Timothy, by all means, please. Yes. Thank you.
Hey, Michael.
Yes, hi.
Hi. I'm sure you probably mentioned this. I just have a very fundamental question. Why do you fork the repository?
So, sorry, I just took a bite of something.
Okay.
When you clone it, it presumes that you have access to the repository, right?
Mm-hmm.
So when you fork it, and by the way, you can do PRs in both. They kind of switch things up for that. But typically, when you fork the repository, you're going to create a complete copy of the repository, and you don't have access to the repository. In other words, it's not yours. It's actually owned by somebody else. Whereas typically when you clone and you're going to commit off that clone, because you can clone any repository, so don't let me make that false. But typically when you clone a repository and you're going to push to the repository, you have administrative rights somewhere in that repository to make those pushes. Forking usually takes the whole repository, like copies the whole thing down, very similar to a clone, but it makes it like yours under your account. Whereas cloning it also makes it under your account, but it's kind of like a linked copy of what's going on back up on the origin. In other words, the origin is still set to the other repository. It can get funky, but the main reason is to create this complete independent copy, and then that way you can just like say, hey, I want to commit to your repository, and you can push it back. But typically, when you've cloned a repository and pulled it down, it's assumed that you have some kind of permissions to get into the repository. With a fork, you have no permissions to the source, and you're going to push a pull request in order to make contributions. So it's almost a different way of thinking of like, are you part of that organization or are you not part of that organization? If you're not part of that organization, you're probably going to fork it. If you are, you're probably going to clone it. But that's more convention than it is security now. So,
Okay.
yeah. Because one branching strategy is to fork the entire repository, which is a little weird. It's like a code repository. You know, you have Git flow and GitHub flow and GitLab flow. These are ways of managing branches inside of a repository. Some teams are like, you know what, we don't even do that. Just fork the entire repository, manage it the way you want to, and then just push your changes back to our main repo. So just know that forking can also be considered in some ways kind of like a branching strategy, but you're actually just copying the entire repo over.
Okay.
Yeah. So it's more of a security thing.
Michael, since we're talking about fork here, so I understand the forks, you just copy the repo and the code, and you do it. I mean, you play with that and within your account, and maybe if you need to, you know, edit something, you find something interesting that maybe it will a good contribution to the original code, then you just you know, request to push and or pull. I'm not sure which. Anyway, and the original, I mean, the owner of that code actually will have to, you know, chat over that portal, and then yeah, if it's okay, then you will accept the merge. Okay.
Right.
But how come? How about like I don't want to? I mean, I don't know. Maybe it's something. Okay, if it's he own it and that he has the copyright, it could be. But I just want to ask a question. Like, if I fork the code here and I played with the code, but I want to do, I mean, apply all the, you know, all the changes on my own. Actually, I don't want to send it to the original. Actually, yeah. Is this I mean, allowed within GitHub here, or it's something related to the copyrights that, oh, if you're changing anything in the original code, then you have to, it has to go through that to the owner of that code. I don't know if I phrase it right here.
No,
sorry.
that was well said, actually.
Okay, thank you.
Yeah, that was well said. So what you're asking is like, what are the considerations basically if I want to fork somebody else's code? Do I have to push back to them? Can I keep the changes local to myself? It really all depends on the license. It depends on the license they're using, right? Now, I do not know the licenses really well, so I'm just gonna admit to that. But like, if the license allows you to fork and then do something else with it, then you can do that. if the license says you can pull it solely for the like task of making changes and committing back to us, that's a different thing. You know, so it really depends on which license they're using. Most licenses are pretty permissive, because if they're allowing you to fork, then they actually want you to copy the code. But they may allow you to keep those code changes for personal use. But if you try to make a copy of their product, then they're going to come after you legally, right? But most of that's done on the honor system. So, you know, you want to follow the license as published. But until you do something that is publicly acknowledged, if you pull something in privately and want to mess with it, that's fine. Do note though that if general rule of thumb is that this is why most open source projects, the licenses are audited for enterprises, just to make sure they don't require you to give back to the project or publish sourcing, or you can't make money off the code. So again, it's all very license dependent, but most of them are pretty permissive. So that's the kind of it depends answer, right?
Oh, okay, thank you, Michael. This is the second training with you. It's the Terraform was really awesome, and this is getting even better. I mean, I wasn't really interested in the GitHub. Maybe you saw my account. I did some projects actually from online.
Yeah, you had quite a few.
I enjoyed
actually.
the experience today, actually.
Yeah, good. Glad to hear it. Do note that we'll be doing Ansible at some point in time, and I will be sending you resources. So just note that if you want to send me an email, you'll have my email address from obviously the previous class, but this is for everybody. Obviously, email me if you have any questions or anything comes up. But yeah, it's a pleasure having you all. You are a lively and interactive bunch, which is great. It's not always the case with people, so thank you.
Thank you very much.
Yeah.
Okay, I'm done with 2 and 3. I will try again with 1 maybe later through my laptop maybe.
Yeah.
I have Ubuntu, by the way, in my personal laptop. So.
Oh, perfect.
But I don't know. I never seen that build actually. That color, it's different. I was kind of weird. Like, is it Ubuntu or? I was like.
Me neither. I've never seen that desktop type before ever. Yeah. Actually, I don't know if that was like. Cinnamon or Mate, or I mean, I'm familiar with KDE and GNOME, so I didn't, or in Unity, so I don't know where that came from. Yeah, if you have Ubuntu, by the way, it should work great. I suspect there's something going on with the distribution, but I don't know.
Okay, thank you, thanks everybody.
Yeah, have a good one.
Michael.
Yes. Hello.
Maybe.
Let's see, you're breaking up pretty badly for me. I hope you can hear me. Can anybody else hear me? Maybe it's me.
No, that's fine. I can hear you.
Okay. Okay.
How about now?
Oh, you sound perfect. You sound really clear.
Great. Sorry, no, it was my microphone. Too many things connected. About the webhooks, a quick question on if you wanted to get like a notification just from a specific, like I'm trying to think of, I don't really have a very good use case, but in case you, like right now we got a notification, right, for an update anywhere on the repo, right? On
a push, yes.
Say I saw that you could if you put in you can put in tags or something to say, okay, send a notification with this push, or, and I'm not familiar how tags or labels work, but I'm just trying to figure out is there a specific way that you could kind of tune the notifications so that you're not sending it with everything?
Yeah, so when you set up the webhooks, you can actually go in and set it up to very like specific events. So okay. Like if you go in actually and edit the webhook that you created, there's an option to say, let me send on like select individual events, and it will do things like you can do branch or tag creation, branch or tag deletion. There's a ridiculous number of events in there. Everything from like, if someone does a release, right, we can do that. And usually if you go in there and do the check boxes, I mean, there's a large number of options. So it's overwhelming actually.
Okay.
There used to be a way, so I'm going to pull this from my memory. There used to be a way to only do it based on regex patterns. To say like,
Okay.
if the event tag, for example, someone tagged a commit. If someone does a tag and it starts with release RC, like release candidate, there used to be a way to do that in repositories that were just Git repositories so that they would show up. I remember that you could do that. I haven't done that in a long time, but I believe that you can still do that inside GitHub, but I don't know what the steps are where you
Okay.
can actually throw in regex. And then of course, once you get to regex, you might as well just be doing sorcery at that point in time. Because you know how it works. You can do anything you
Yeah.
want. Yeah. So but I haven't seen that in a minute. Most people just hook it into their build servers and do off of base events. But I know
Okay.
that's the way you used to be able to do it. So I suspect that still exists.
Okay.
But I think you'd have to look at the developer documentation for webhooks to dig deeper into that. But at least
You
you
know,
know
it's
you
just
have 60 events you can choose from.
yeah, it was just to get an idea of the use cases, right? Because depending on what kind of repo it is, the notifications could be noisy or not, right?
Well, and also like you could, like if you did a release, your webhook could trigger an email out to everybody and then post on the Slack and then post in the Discord. Do you know what I mean? Like,
Yeah, pull the
'cause, like,
update and
yeah, and then that way you don't have to, like Kubernetes does that. I'm on all the Kubernetes like Discord and Slack channels and whatnot. And when they post a major release, like it's like 1.21 or whatever, it automatically posts via their webhook out to all the channels. So
that'd
that's
be
a
great.
cool use case because then you can
Yeah,
just
I can
let
actually
people
see a
know.
use case for that now in our team. Yeah, when we
Yeah.
put out the new version. Great.
Yeah. And if like you get like a merge conflict, for example, we used to have a board where someone posted a build and the build broke. It would paste their name up on our TV.
Oh no, they're
Yeah.
facing
It would be like the build broke, but it was a joke. We would never shame anybody,
Okay.
but it was always like a joke because it was always in good humor. But it would like let them know, and people would be like, "Oh, you know what? Forrester's got a broken build," and be like, "Man, what did I do?" And then what would happen is that anybody who made a comment about it had to go help the person resolve the build.
Oh, okay.
That
Oh,
way
that's good
right?
actually.
In other words, you could make fun of them, but only if you would go and help fix the problem. So it kind of drove collaboration in a very fun way. But it also made it so for those people who didn't want to have mistakes, they would ask the people ahead of time so they didn't show up on the board. Right? Because that was the thing,
Yeah.
is that you never went into problems alone. But yeah, so that's another use case, is that you can drive collaboration with it.
Great.
Yeah.
And while I have you, I just wanted to say thank you very much. It was a great session. It's Friday evening here in Barcelona, so it's not the best time for a learning session, but I found it very entertaining and very useful. So thank you very much. I really enjoyed it.
Good. So wait. Just to check, did you say that correctly? Because I could have sworn I heard you say Barcelona and not Barcelona.
Yeah, if you're speaking Catalan, you can say Barcelona.
I see. I gotcha. Yeah. That's great. Well, thank you for joining us, and I appreciate you joining so late. That's great.
No,
Yeah.
thank you very, very much. I really enjoyed it. I'm gonna fill out the survey now.
Awesome. Thank you. And it's my birthday. Woohoo!
Happy birthday!
Happy birthday.
Yeah.
Great day for a birthday,
happy
Friday.
birthday.
Yeah. So I don't know if you saw it, but people they were going behind me. They keep bringing cupcakes over. I got a pile of cupcakes.
Oh,
over here.
nice.
I'm like, I'm not going to eat all those. So yeah. So it was good. Yeah. When they said, "Hey, do you want to teach?" and I was like, "Oh, absolutely." And they were like, "Well, we're going to have you run until noon." I was like, "Yay, let's do it. That sounds like fun." So good.
All
So,
right.
so thank you for joining me on my birthday.
Thank you, Michael. I'll be dropping off. I have
All right, Falguni.
completed the exercises. Yeah.
Awesome.
Thanks, Michael. I'm dropping off as
Thank
well.
you.
And
All right,
happy
Pablo.
birthday.
Thank you. Thank you.
I will also drop off. Thank you for your time to teach us, and yeah. Congratulations for your birthday.
Thank you.
Sorry, we cannot send you any cake.
That's okay. I don't actually need any. And thank you, by the way, for your help on the language thing, because I'm gonna make sure the language are installed in the base images. So I appreciate that for all the Santa Fe labs. So that's very helpful. Thank you again.
Yeah. Thank you.
Yeah.
Hey.
Have a good one.
So one question: how can we delete our repository on the GitHub.
Well, that involves a little sacrifice. So oddly enough, if you go into settings on the repo, oh, I forget every time where this is at. Is it under options?
Michael,
I think it's under options actually.
Michael, happy birthday. I
Oh.
have to drop off.
Thank you. Hey.
I have it was a fun moment with you. I have met a problem, but I fixed myself. It's about the repository path. I type // and it wasn't not correct to onboard on the GitHub web page. So I corrected that, and
Okay.
it works. All labs works fine.
Perfect. I'm glad. I love hearing that you fixed it yourself. Not that I don't love troubleshooting,
Yes,
but I love that you figured it out.
Yes, because you are very busy.
No, no worries. I could have helped, but okay, good. I'm glad. Great. Good job. Thank you. Yeah. All right. We'll see you next time.
Yes, see you. Bye bye.
Andrea, so if you go under settings for the repository,
Yes,
click on the top one,
okay.
options.
And then delete. Okay, type to confirm. Okay.
Oh yeah, they force you to type the whole thing out.
So you have to do the same. Okay, and then I will say I understand it. Okay, and then it should be removed. And the other one I will also remove. Okay.
Perfect.
Thanks a lot. Yeah.
You're welcome. All right. Thanks for hanging out with me, and great questions, by the way. So I really appreciate that.
Yeah, and also have a nice evening and thanks a lot. Bye.
Thank you. Bye. Take care. All right. Stop that. And stop that. And is that it? Okay. We're all done, Forrester. It's just you by yourself. Happy birthday. All right. See you later. Bye.